In this screencast, we are going to study polynomials and the arithmetic associated with them. Polynomials are extremely important in mathematics. They actually show up in a lot of applications. For example, if you wanted to model the height of a baseball after it's hit as a function of time, you would need to know something about polynomial functions. So we're going to look at what a polynomial is. We'll define some terminology associated with them, and we'll also do arithmetic with polynomials. First, we have the definition of a monomial. A monomial is a real number, a variable, or a product of numbers and variables. For example, 7 is a monomial. -5 is a monomial. X is a monomial. Y is a monomial. -7x, y is a monomial. 7x squared y cubed, these are all monomials because it's either a real number, a variable, or a product of numbers and variables. So you might be looking at this one saying, wait a minute, but remember, exponents are representing a product. So this just tells you you've got 7 times 2x's and then times 3 y's. So each of these are examples of monomials. Notice there are no sums or differences in these expressions. A polynomial now is the sum of monomials. So for example, 7 plus x is a polynomial. -5 plus x plus y is an example of a polynomial. So polynomials are sums of monomials. Before we get to doing arithmetic with polynomials, there is some special vocabulary that goes with them. First is a couple things down here. A binomial is a polynomial with how many terms? Well, bi, that prefix means 2. So a binomial is a polynomial with 2 terms. What then do you think a trinomial is? Well, the prefix tri represents 3, so a trinomial is a polynomial with 3 terms. 7 plus x is an example of a binomial, and -5 plus x plus y is an example of a trinomial. Let's take a look at a few more terms associated with polynomials. The leading coefficient of a polynomial is the coefficient of the term with the highest exponent on the variable. We're going to look at a couple of examples in a moment. The constant term of a polynomial is the numeric term without a variable, and the degree of a polynomial is the highest exponent on the variable. We are primarily going to be working with polynomials of one variable in this class. So notice there's just x in here. X squared, of course, is related to x. It's x times x. There's not an x and a y, for example. So we're going to look primarily just in polynomials of x, which these are 2 examples of. Let's go through and name these polynomials. Let's find their leading coefficients, their constant terms, and their degree. The name of each of these is based on what we saw on the previous screen. We've got a polynomial here with 3 terms, which we would then call a trinomial. So the first one here is a trinomial. In this case, there are 2 terms. This would be called a binomial. Let's now look at the leading coefficient of each of these. Again, the leading coefficient is the coefficient of the term with the highest exponent on the variable. Notice this term has the highest exponent on the variable, specifically this 2. So the leading coefficient is the coefficient of that term, which is -5. Leading coefficient does not always mean that number will be out front. Let's take a look at this one. We've got 4x squared minus x cubed. Now, the terms of this expression are 4x squared and -x cubed, because remember, the terms are parts of the sum. So this would need to be rewritten as plus the opposite of x cubed. So notice this term has a higher power than this one does. So this term has the leading coefficient, and the number that is out front here is technically a -1, because the opposite of x cubed is -1 times x cubed. So the leading coefficient in the second one is -1. What's the constant term in each of these? Well, the constant term of a polynomial is the numeric term without a variable. So again, this needs to be part of a sum. Polynomials are part of a sum. So the constant term here is -4, because this would be -5x plus 7x plus -4. So the constant term is -4. Here you don't see anything being added on. So what number can you add on to an expression and not change it? That's specifically the number 0 in the real number system. So it's not that this does not have a constant term. You just don't see it. The constant term is 0. And then finally, the degree. The degree of a polynomial is the highest exponent on the variable. Well, you've got your variables here. The highest exponent is 2. So this is a degree 2 polynomial. And the highest exponent of these two is 3. So this polynomial down here is a degree 3 polynomial. Now that we've looked at a bunch of terminology associated with polynomials, we'll take a look at evaluating polynomial expressions at particular numbers. So what we want to do here is we want to evaluate the expression the opposite of x squared minus 7x plus 1 at each of the following values of x, at x equals 3 and also at x equals negative 3. It's worth pausing the video here and actually doing these computations. There are a fair amount of common errors that students make when they evaluate polynomial expressions at specific numbers. So my tip for you to do this is to always plug the number in with parentheses around it. So instead of just putting 3 in place of x in here, I'm going to put a 3 with the parentheses around the 3. So for this one, I'm going to write everything exactly the same, except in place of the x, I'm going to put the 3 with parentheses around it. So we've got that negative sign, we've got in place of the x, we've got the 3 with parentheses around it, and then we've got this square up here. Then we've got the minus 7 times x. In place of x, though, we're going to put that 3 with parentheses around it, and this means multiplication when you put those next to each other, so that's good. Then we also have the plus 1. Now notice, we are not squaring negative 3. We're squaring 3 and then taking the opposite of that. The square of 3 is 9, and the opposite of 9 is negative 9. Then we have minus 7 times 3 is 21, and then we've got plus 1. And to complete this, we do this from left to right because subtraction and addition are on the same tier of the order of operations. We've got negative 9 minus 21 is negative 30. Negative 30 plus 1 is negative 29. So this polynomial expression is negative 29 when you plug in 3 for x. Let's try this again, but we'll plug in negative 3 here. So again, I highly suggest you plug in the negative 3 with the parentheses around it. And we've got, of course, this negative sign here. We've got the negative. In place of x is the negative 3. Then we've got the square. Then we got the minus. We got the 7. In place of the x, we're going to put the negative 3 with the parentheses around it. And then we also have the plus 1. Notice here that we are squaring negative 3 and then taking the opposite of that. A common error from students is to say, oh, the opposite of negative 3 would be positive 3, and then you square that. That is not true. Because taking the opposite of something is like multiplying by negative 1, you have to do this exponentiation before you multiply by the negative 1 or take the opposite. So we are simply squaring negative 3. Negative 3 times negative 3 is positive 9, and then we want the opposite of that. So we get negative 9 to start here again. And then we've got minus 7 times negative 3 is negative 21. And then we have plus 1. And don't forget that subtracting a negative number is the same thing as adding a positive. So this is negative 9 plus 21 plus 1. Negative 9 plus 21 is 12. 12 plus 1 is 13. So when you plug in negative 3 for x in this expression, you get 13. You should be able to comfortably evaluate polynomial expressions at particular values of x.